today. Welcome back to another chemistry class. So today we want to continue the topic volumetric analysis. Now today I'll be explaining titration in a bit. Remember I told the last class that volumetric analysis has to do with titration. Now what is actually this titration? We'll be hearing titration. Now you all know that the reaction between an acid and a base is a neutralization reaction. Now, we are preparing a solution of acid. If you say titration, that means you want to combine this acid with this base at a particular volume. So we want to know the exact volume at which this acid completely neutralizes the base. You can only get this with the use of an indicator. And this indicator depends on the type of acid and the base you are combining together. Now here we'll be looking at the reaction between potassium hydroxide and H2SO4. The two are both concentrated solutions, so we can make use of an indicator called methyl orange. Now if you drop, after pipetting like 25 cm cube of your base into a conical flask, you have like 2 drops of methyl orange. Now you start titrating. How do you titrate? You release the valve where you have poured the acid inside the burette. When you release this valve, the acid starts dropping into the conical flask at a particular volume. The color changes. You have to stop introducing the acid at that particular volume because that is when the acid has completely neutralizes the base. So you have to stop at that particular volume and you note the volume. You can carry out the titration process like 2-3 times because we usually have a rough titer. And this rough titer simply means maybe you did not detect the color on time, your hand was shaking, you released the valve too much, or your pipetting of acid. You know, a lot of things can happen during the rough titer calculation. So we have the rough titer, we have the first titer, and we have the second titer. So in a nutshell, after having your table, this is how the table looks like. We have our burette readings, we have the rough titer, the first titer, second titer, and the third titer. Now to get the average volume of acid used, you have to add up all this titer. I did not add up my rough titer because the rough titer was too high. Now look at the difference. This is 27, this is 24. It was too high, and when I made the second and third titer, it was closer to the first titer. So I decided to pick the first, second, and third titer. So you add up this first, second, third titer, divide it by 3, and you have your volume of acid used, the average volume of acid used. Average simply means you divide it by this 3 here, and you have your average volume of acid used. Now, you must know the equation of reaction. Yes. When you are calculating anything under titration or volumetric analysis, you must be able to write a complete chemical equation. Now we have the reaction between potassium hydroxide and H2SO4. When you balance the equation, we have 2 moles of KOH and we have 1 mole of H2SO4 here. Now there's something we call CAVA over CBVB equals to NA over NB. These are the meaning. Ca simply means concentration of A in mole per dm cube. Cb means concentration of B in mole per dm cube. Va means the volume of acid in Cm cube. Vb means the volume of the base in Cm cube. Na means the number of moles of A. Nb means the number of moles of B. Can somebody please get me a calculator, please? Now look at this one. This is what we want to calculate using all those parameters. Now we're given 25 cm cube. This simply means we pipetted 25 cm cube of the base. We pipetted what? 25 cm cube of the base. Now 25 cm cube of 0.1 molar. Remember in our previous class I said your molar concentration can be written in capital letter M or mole per gm cube. Now you are given 25 cm cube of 0.1 molar potassium hydroxide needed to neutralize 24. This is how we got our 24. This is how we got our 24 here. Of H2SO4, whose concentration in gram per dm cube is to be determined. So the question here says we should calculate the gram per dm cube mass concentration of the acid. But how do we calculate the mass concentration if we don't know the molar concentration? So that is where we are going to apply our CAVA over CBVB equals to NA over NB. Now what is our CA? That is what we are looking for. We have our CA times, what is our VA? What we got here, 24, over, what is our CB? It has been given to us in the question, 0.1. What is our VB? Our VB is 25 because we used 25 cm cube of the base. What is our Na? That of the acid is 1. The mole ratio, 1 over 2. So let's cross multiply. What do we have here? Ca equals to 0.1 times 25 times 1 over 24 times 2. So here we have 2.5 over 48. Let me make that calculation. 2.5 divided by 48. Here we have 0.052. So here we have 0.052. What will be our units? Because we are calculating the molar concentration, it will be in mole per dm cube. It will be in mole per dm cube. Now the question says, calculate the concentration in gram per dm cube. Last class I explained to you that mass concentration equals to what? Molar concentration times the molar mass. What is the molar mass of H2SO4? It has been calculated here, 98. What did you get as our molar concentration? 0.052 times 98. Multiply it by 98 times 98. What do we have here? 5.104. So the mass concentration of H2SO4 is 5.1 gram per dm cube. The mass concentration is 5.1 gram per dm cube. So we can see the relevance of this CAVA over CBVB equals to NA over NB. If you are told to find your mass concentration, you have to look for the what? The concentration in mole per dm cube. Then you use the formula here to find your mass concentration. I hope you understand that. Alright, see you next class. Bye.